All right, good morning, everybody. Welcome to another session where we are continuing our discussion on patterns and sequences, focusing on numbers and trying to understand and get used to the language that we're going to use to explain the patterns that we see. Sequences. Let me just scroll here. All right. See if working. Seems to be. Okay, good. All right. So let's remember what we did last time. We looked at an example sequence. Oh, that pen is just way too big. Why is it big? There we go. We looked at an example of a sequence 1, 4, 7, 10, 13. Something where the pattern was fairly obvious. And if it's not, it's easy to convince yourself that you just add 3 every time. And we learned how to explain this pattern in the mathematical language in 2 parts. We have to say what is the first term. Our name for the first term is A1. We have to give the instruction. Where do we even start? In order for me to start adding 3, I need to have a starting point. Okay, it's 1 in this case. And then I need to give a more general instruction for how to go from one to the other, or in other words, how to find the term in a general position. Could be the second one, could be position 2, could be way deeper into the sequence. But always I would find it by taking the previous one, the position 1 before, and adding 3. And I would do that for finding the second position, the third position, the fourth position, and as far as I want to go. So this, in a sense, is a formula. Well, it is a formula. A set of instructions for how to make this sequence. We call this a recursive formula. That's an M. Recursive just means I'm using previous terms in the sequence to find new ones. I look back. In this case, I look back to just the previous one, do something in a calculation to find the one I'm looking for. But we can have another kind of formula. If you remember the example from yesterday where we looked at, let's do this example here. It was 1, 4, 9, 16, 25, and so on. Where we noticed different ways of looking at this. Yes, I can take this recursive approach, but what I'm adding is not quite the same every time. I'm adding 3, then 5, then 7. Okay, it's not impossible, but let's think of the other way we thought about this. By linking the term to the position that it's in. And we notice that the term is the square of the position value. So in this case, I can explain how to make this sequence by giving someone the instructions. Start at position 1, which we always will do, and take the position value, the position that you're in, and square that, and create your sequence of numbers. Then they'll be able to make 1, 4, 9, 16, 25. So in terms of instructions in the mathematical language, we would say, okay, to find the term in position n, remember n can be any position you want. It can be the first position, it can be the second position, third position, 100th position, it doesn't matter. It's a general set of instructions. But in this case, it looks different. In this case, I use this position n, the position value in the calculation, and I multiply it by itself. So notice the difference between how these formulas look. They both have the goal of explaining the sequence that they want to explain. They both have the goal to give instructions for how to make a sequence. But they don't look the same. The first one used previous terms themselves, did something to them to find new terms. The second one doesn't do that. Second one doesn't use any other terms in the sequence. It simply uses the position that you're interested in and does a calculation on that. Different way of explaining the sequence. We'll call this an explicit formula. Pros and cons. Pros and cons to these. A pro of recursive formulas, they're usually pretty easy. They're easy to build because it directly translates a very easy pattern that I could do in elementary school, and I probably would at some stage. First start with pictures and then something like this. A con is that I don't have the luxury of skipping ahead. I need to do, so I must find terms in sequence. I must find a term, the next term. Then I can go to the next one. Then I can go to the next one. But perhaps I'm only interested in the 100th term. I don't care about everything in between. This does not allow me to do that. I have to go one at a time. Pros and cons. When it comes to the explicit formula, pro and con. The pro is that it fixes the con of the other one. I can jump to wherever I want because all I need to calculate the term is the position. If you want to be in position 1000, you don't need to know anything that happened before that. You use the position you're in. Simple. So it has that efficiency, that flexibility that the recursive formula simply does not have. But a con is it can be more difficult to find. It can be more difficult. Not will be every time, but it can be a little bit more tricky. You have to pay a price for that pro. For the luxury of jumping around, you're going to have to pay a little price, and the price is a little bit more complexity in finding that formula. However, that's not a concern for us right now, because first up is just reading and interpreting the formulas. So when I start out with a language, the first thing I want to be able to do is read it. Before I write it myself, I need to be able to read it. So we have a couple of exercises. I'm actually going to do 1.4 first, because the explicit formula, in terms of reading, the explicit formula is certainly easier. When I don't have to write it myself, then it's a manageable job. So let's go to exercise 1.4. Just trying to position my page here so that I can still see if there are questions. Leave that page open here in case we need to refer to it. Make a new page here. Okay, so in exercise 1.4, first one, all it says is just read the formula and find the first 5 terms in the sequence. So first of all, this is my formula. What kind of formula is it? What kind of formula is it? No one has said anything today. I'm starting to worry if you can even. What kind of formula is this? So the very first thing is we need to know what the 2 types of formulas are, right? What is the basic language? What's the basic things we need to be able to read in this language? Like 2 kinds of sentences, right? So then how I decide that is I ask myself a question. Does this formula, in order to find a term, it's trying to find the term in position n, right? An. Does the formula need previous terms in the sequence in order to find that? Yes or no? Or does it just use the position value? That's the question. Does it use previous terms, previous A's in the sequence in order to calculate its value? No, it does not. No other A's, so to speak. No previous terms in the sequence. It does not. It is an explicit formula. Now, of course, standard rule, I have no issue with someone saying something that's not quite correct. That's part of learning. I would rather have you say something so I can get feedback and see how you respond to some of these little questions. Then we know where you're at. It's important. Don't ever worry about saying the wrong thing. Rather say something. All right. So now I need to make the first 5 terms in the sequence. That's what the instructions are in the question. So to find the first one, arrow here, I would simply plug it in. Its name is A1. That means n is equal to 1 for my immediate purposes here. Put in the value of n. I get 3 times 1 minus 1, which is 2. Find this one, second position. That is A2. N is equal to 2 for my immediate purposes now. Whoops, 3. That's an ugly 3. 3 times 2 minus 1 is 5. Next position is 3. Plug it in. 3 times 3 is 9. Minus 1 is 8. Next position is 4. 3 times 4 is 12. Minus 1 is 11. Next position. Now, even if you see a pattern here, use the formula. Because if it's more complicated formula, that pattern might not continue. You can't trust just 3 or 4 numbers in the sequence and think you know the pattern necessarily every time. Use the formula. 5, 3 times 5 is 15, minus 1 is 14. It is fairly simple in this case. All right. Any questions on reading this formula while I have a look at the next one? Now, I don't need to slide this back and forth every time. They're simple enough to just copy. Okay. Reading the language comes first. Then we'll worry about writing in the language. So here we have our next formula. Yes, that's right. First of all, decide, is it a recursive formula or is it an explicit formula? What would you say? That could be a test question. It could be an oral test question. What is the difference between an explicit and a recursive formula? That's not something you need to calculate, right? You just say it. That's an example of an oral test question. Or I can give you a formula. Is it a recursive or an explicit formula? In this case, it is an explicit formula. That's what we said previously. Yes, good. Because it does not rely on previous terms to find this term. It's not recursive, then it is explicit. So I want to find the different terms in these positions, the first 5. So I'll do the first one by writing it out. First term is called A1. For my immediate purposes, n is equal to 1. So I plug it in. 1 squared is 1 times 2 is 2 plus 1 is 3. Then next one, n is equal to 2. Plug that in there. N squared is 4 times 2 is 8 plus 1 is 9. Next one, n is equal to 3 for this one. Plug it in. 3 squared is 9 times 2 is 18 plus 1 is 19. Let's have you do the next one. What is the fourth term in the sequence? Maybe by taking part, can you determine where you're at, how you feel about these things? And by trying something, maybe you realize questions that you didn't quite know before to even ask. Many people have questions sometimes, but they don't know what to ask. Well, by trying something, it becomes a little bit more clear, perhaps. $33. Well, n is equal to 4. 4 squared is 16 times 2 is 32 plus 1 is 33. Perfect. And then you feel good when you get it right as well. And if you don't get it right, don't need to feel bad, but it's always the good thing, because then we have something we can fix before any sort of test happens. And then 5. 5 squared is 25 times 2 is 50, so 51. So right now it's about reading the formula. And explicit formulas are quite easy to read because you know what position you want to be in. You plug that in for n, you do the calculation it says. It's quite straightforward in terms of reading and using it. The con was coming up with it is a different game, but one thing at a time. All right. Now, some people struggle with reading recursive formulas a little bit more, which is why I left exercise 1.3 and wanted to do this one first. So I'm just going to copy it down. As soon as I move it to the other screen, it hides the text. So annoying. Screen resolutions, that's my problem. Okay, so now it's exercise 1.3. And I have the first one. Again, it's about reading. I'll write it like this. One below the next one is a little nicer. Now we're just jumping in here. Oh no, it's medium jump. Not jumping in at the deep end. Sort of medium. All right. First issue, is it a recursive formula or not? Now I do see, feel free to interrupt me at any time. I do see the presence of an n That doesn't make it explicit. The presence of this A makes it recursive. That in order to find a term later on in the sequence, I need to look at previous terms to find it. That makes it a recursive formula because it uses previous terms in the sequence to find the term I'm interested in. All right, so I have 1, 2, 3, the same goal. Need to find the first 5. Position 1, position 2, position 3. Now this one is maybe a little bit more spicy because it uses the position value as well as previous terms. It can be whatever it wants to be. I just have to use it. Okay. So let me write out the first couple at least, and you can let me know how it feels. So when I want to find the first term, it's the first special case. It's listed separately from the rest. Because in a recursive formula, I need to have a starting point before I can start looping this together. So there's nothing to do there. You simply put it in. But for the second term, maybe there's a little more to do. So the name of that term is A2. For my purposes, right now, n is equal to 2. So that formula tells me in order to find A2, I need to look for A1, 1 position less, and I need to add 3 times the position value, which is currently 2. I then do that. Let's do it like this. Well, A1 is already found. It's 2 plus then the 6 there to give me an 8. Now, often people struggle with this perhaps initially because they don't want to write little things like I just did to help themselves figure it out. They just want to do everything in their heads, or if they're unable to do that, oh, well, I guess I'm just stupid. Math just doesn't work for me. My brain just doesn't work that way. No, give yourself a chance. This is new. Scribble little things to help you structure your thoughts and get to the number. You're not impressing anyone by writing less. In fact, I want to see more in a test. It's way easier to grade and assess your understanding if you have more detail on the page. Way easier. Next one, let's loop it over here. That over there. Okay, so I am in position 3. I'm looking to find the term in that position. It's called A3. The formula says, well, in order for me to do that, I need to find A2 plus 3 times the position value of that current position, which is 3 as well. So that would be, I look to the previous term, 8, plus the 9, and I get a 17. Then, let's see if we can do position 4 ourselves. Now, perhaps you need to scribble some stuff. Perhaps you weren't ready and you don't have any paper. Freaking out. Now you know. Or let's try and just talk through it and see how that feels without the help of little scribbles, though you can always do little scribbles. It just takes a little bit longer. I'm starting to interpret this. I'm starting to see the mathematical language sentence, but translate it to English in real time. If you're proficient in, let's say, French, right? You can speak, you're fairly proficient. You can look at a French sentence and in real time say it in English. Translate it as you go. It's no different here. I can look at this and say in English what it's saying. To find a term, look at the previous term and add 3 times the position value. In real time, I'm translating it to my language because I can read this language well enough. So in order to find the fourth term, I take 17, the one that came for it, before it. I can't even speak properly. 17 plus 3 times 4. 17 plus 12, and I get 29. Now, you don't have to be comfortable with doing it in your head right now, but I do admit eventually it'll be nice to be able to do that, since writing everything out can be time consuming. It's really up to you. I've seen people always do these little extra notes just for safety, and they don't run out of time. It's fine. So it's really up to you. It's really up to you. And as you get more proficient with the language, you'll naturally just start to say what this instruction says in English. You'll just say it. Oh, it's the previous term plus 3 times the position. Okay. But that happens for everyone at a different speed, right? Let's do the last one with notes again. I'm in position 5. The previous term is a 4 plus 3 times the position, which is 5. A4 is 29 plus 3 times 5, which is 15. And I get my 44. So decide, what do you need? If you're not ready to just write the number in with confidence correctly, and you need this little extra notes, absolutely do it. You're not impressing anyone by not doing it and making a mistake. The last thing we want is a mistake. Okay? So do what you need to do, and it'll naturally get easier as we go. Right, let's try the next one. Oops, let's not. That page is done. Let's position the page. Let's look at the question. All right, so this is number 2, where they tell me A1 is equal to 2, A2 is equal to 5, AN is equal to AN minus 1 minus 2AN minus 2. Blech. And that applies for n equal to 3, 4, 5, and however many I want. I just want the first 5, according to the question. So I don't need to write the position values underneath. I choose to because it helps me. Over here, okay. All right. So now, what do they say here? The first term is 2. There's nothing to do, it's a 2. And they give me the second term. Why do they do that? Because if I look at the third line here, to find a term, it uses 2 previous ones in the sequence. So it makes total sense that if I don't have the first 2, I can't actually get the ball rolling here. So now let's find the term in position 3. Only three terms are missing. Nice. So for my immediate purposes, n is equal to 3. It says, look at the term right before it, see 1 position less, which would be a 2, because 3 minus 1 is 2. Subtract 2 times the term 2 steps back from where I am. 3 minus 2 is 1. See? 2 positions back. I then calculate that. Well, the one right before me is 5, minus 2 times the one right before that is 2. 5 minus 4 is 1. I do whatever the formula says. It doesn't have to always go increasing or decreasing. It can go up and down, whatever. I don't know. Let's do one more in this way. If I'm now at position 4, I'm trying to find a 4. It says look 1 back, which would be a 3, and subtract the term 1 back from that, which would be position 2. A3 is the one right before where I am, 1, minus 2 times the one before that, which is 5. So 1 minus 10, so I have negative 9. Let's see if we can do the last one. Awfully quiet. That is not filling me with confidence that everyone is okay so far. It's up to you, remember, whether you want to do it in the live session or you want to do it later. If you have questions, you need to address them one way or another. Figure out what your questions are and let's fix them. So let's see here. Let's talk through it. I need to talk through it. I don't know the answer. I need to think about this. But as I get more comfortable with the language, I can read this. Okay, what is this saying? This is saying to find a term, look one back. Okay, I want to find this term. So I look one back, so negative 9 minus 2 times 1 back from that, which is 1. So negative 11. Again, there is no need to try and impress anyone by doing it this way. I do it now and then to just see where I'm at and how comfortable I feel. If it turns out like, whoop, I'm not ready for that, I need my scribbles, then do the scribbles. It's fine. Let's do another one. I'm just going to make a line here. Shift it down a little bit. Position 6. Why is that 6 so big? I don't know. It's scaring me. I like to make the positions nice and small. Here. Let's write it out again. I'm in position 6. I'm interested to find this term. So n is 6 for me right now. So what I'm looking to find is A6. This tells me how to do it, regardless of what my n is. Right now it's 6. I need to find A5, which is one position less than where I'm at, which is going to be negative 11. Subtract 2 times, why is there a bracket? N is 6, so minus 2 is 4, which means 2 steps back. See, 2 steps back. And A4 itself is negative 9. Oh, that sucks. Okay. So negative 11 minus 2 times negative 9. So that's plus 18. So that is a 7. It's just getting used to the language and learning how to read it. That is our first step, our first goal. And it's not easy. Said it was easy. Imagine learning another language. Would that be easy? No, of course not. That would be really hard. Really hard. So we have some, I'll show you here. As soon as I switch to the screen, it either becomes really big or really small. Can't win. If I look at some problems, the one closest to what we've done is problem 1.4, where again, find the first 5 terms. Can you even see this? It's not super big, but find the first 5 terms. So it's just about reading. There's some other things here too to get you warmed up, but the one closest to the exercise is this one. Okay. So at the very least, do that one, and maybe do it first. Maybe, because then you have working examples here that you can build on when you look at those problems. Okay, that's not the button. Okay, so hopefully it's starting to feel okay. Maybe. What is the key to successful language learning? Time is the key. It takes time. And we're fortunate to have quite a bit of time. Not. It's important. Okay. So here are some basic sequences just to get us going a little bit, and to not have things be too open and varied and a little intimidating. Like I can just get anything. Let's narrow it down and let's focus on three, why three? Four basic sequences. The first one is 2, 4, 8, 16, 32, and so on. These are, when you look at the positions, first position, 2, and then a 4. These are powers of 2. This it has a formula, an equals 2 to the power of n. N is the position, right? So the first position would be 1, 2 to the power of 1, 2. Then 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. These are powers of 2. Then, just to not have just one of these, we can look at powers of 3 as well. Powers of 3. And of course, there are more of them, but I don't want to have to remember too many of these. So let's just take powers of 2 and powers of 3. Then one we've seen before, 1, 4, 9, 16, 25, and so on. These are square numbers, the position squared. We've seen that one before as well. Now, when we did this first sequence, we just looked at multiplying by 2 recursively, right? It has an explicit formula, which will be easier to use. The downside to another downside to the recursive formula is, yes, I must find the terms in sequence, and it's very difficult to actually use past finding a few terms. It's very difficult to use. I'm stuck with it. It's really hard. And what often happens further on in the topic is you have to rewrite this to an explicit formula before you can actually use it. It's a very direct translation between the two languages, but it's not very useful, to be honest. Useful in that first understanding step, and that's pretty much it. So then I have my last one, which will be the cube numbers. The position value cubed. So remembering the first 5 of these will be more than sufficient. They are very different. They're not the same. And I don't want to have too many of these because remembering them might be a little bit tricky if I have too many. But I also want some variety. So I settled on 4 as a nice balance between those two. Now I want to keep these on the screen and jump back and forth. So I'm just going to make another new page with our last exercise on it. And it's exercise 1.5, where I want to use these sequences to find an explicit formula for a sequence that's related to them. Let me show you what I mean. The sequence is 3, 5, 9, 17, 33, and it continues. But the first 5 would be sufficient. Now my first issue is to match this with one of these 4. Somehow, this given sequence is built on one of these 4. By making some small adjustment to one of these, I'll be able to get this sequence. So my first question isn't find the formula. My first question is, which one of these basic sequences is it connected to? Just check the question here. I'm not sure which ones you are referring to. We've done many. These basic sequences are all explicit. because none of them rely on previous terms. They just rely on a calculation that involves the position. It's a different calculation, I'll give you that, but it's still just the position value that is used. There are no A's used to find the terms. So they're all explicit formulas. So I'll give you a clue here for the first one. If I look at this very first sequence, the powers of 2, and just write it underneath. So let's say over here, I'm going to write my powers of 2, which has that formula. It's 2, 4, 8, and I'll line them up nicely, 32, and so on. My question is, of course, now what is the link to go from the given, from my basic sequence to the given one? If I can explain that in words first, then the formula will be much easier to write. What is being done to this basic sequence in order to get the given one? All I'm doing is keeping the terms in their positions, just adding 1 every time, and I get the new sequence. So I can do that then to this general form that defines this basic sequence as well, to get how to find a term in the new sequence, by taking that basic one and adding 1. So even though these are both AN, it's a different sequence, right? It's just a general rule. These aren't identical or anything. It's just a new rule. So don't get confused. I don't use the rule at the same time. One defines one sequence and the other defines another sequence. So by just comparing it first to one of these basic sequences and then trying to identify what is being done to that basic sequence, it makes finding the formula easier. Because finding these explicit formulas in general is a little bit tricky. So I want to give us a fighting chance by having a small collection of basic things I can build on. And of course, now I have a lot of variety, right? I can add 2. I can subtract 1. A lot of different things I can use to make a new sequence from this first basic one. Now I lost my questions here somewhere. Let's open it again. So I just have a few of these I want to practice. Number 2 is 2, 8, 18, 32, 50, and so on. And I'm trying to find what is that formula. But before I can do that, I need to figure out what is this, which one of these 4 basic sequences is this closest to? Now that's tricky. But luckily I only have 4 of them, right? So you could line it up with the first one and see, is there a way to simply do something simple to this first sequence to get this one? Well, I'm jumping back and forth now because I know it's not that one. It starts 2, 4, 8. So the first one is a 2 and a 2. So then nothing happens. But I do need to do something to the next one, something different to that one, to get 2, 4, and 8 to somehow transfer to this sequence. That doesn't seem very simple. It needs to be something straightforward and consistent to be the one that I want to use. Next one is 3, 9, 27. I'll write it here maybe. 9, 27. You see here, okay, so this is close. Maybe a subtraction of 1. Subtraction of 1 works again, and then it falls apart. So I do need to check them all, because it could work a little bit and then fall apart. See, so this one doesn't seem like something consistent is happening throughout. That's okay, I have 4 of them. This one, 1, 4, 9, the square numbers, 1, 4, 9, 16, 25. Is there something consistent that's a link between these two? Yeah, I'm just multiplying by 2 every time. So here I'll say here add 1. Here it's a multiplication by 2. Every time it works. Okay, that's the winner. Now this one has formula an n squared. Some space here for us. So this one is going to be an adjustment, just like I said here, 2 times n squared to give the formula for that sequence. And of course, now I could see, oh, I could build different things. I could divide by 2, I could multiply by 3, but there's multiplication as an option as well. Okay, so we just have a handful of basic sequences, and we can create many others. And by understanding in words first what the link is, I can then translate that link in the formula. 2 more. Hopefully we have enough time. 1, 2, 4, 8, 16, and so on. Now to speed this up, I'm just going to give you, because I'm running out of time a little bit, I want to connect it to the first sequence. I try a lot of them. This one has a pretty close link in that I just realized from my experience now, if I could multiply, I can also divide, right? And this one is going to be a division. Divide by 2, divide by 2, divide. Every time it works. Great. It's as easy as that. So the basic one was powers of 2 to the power of n. This one I'll write in a couple of ways. I'll just write it like this maybe. And now if I simplify fractions, remember this is 2 to the 1. If I move it to the top, it becomes a negative exponent. So that is the same as 2 to the power of n minus 1 by just simplifying the algebra. Now there's nothing wrong with this. It's good. It's correct. Leave it like that. Perfect. In this case. But it does tell me I can look at this another way, which in some cases is kind of the only way. Both of these are correct. It's the same formula. But I could look at this basic function as being adjusted in a different way. Let's just rewrite everything because there was nothing wrong with the division. But sometimes there are multiple ways to do things, and sometimes I have the choice of either one, sometimes I don't. So it's good to see it in this example. I could have gotten the given sequence, so this is the new sequence, this is the basic one, right? Powers of 2 are the basic ones. I already have the formula, so it's not about finding the formula, it's about finding a different connection. I can also get the new sequence by shifting everything over one position. Now, this is powers of 2, so technically this is 2 to the 1, 2 squared, 2 cubed. If I go left in order to shift something from the quote-unquote left, hidden side, to get the new first position, it should probably be 2 to the power of 0, right? The powers go down, which is 1. So it does work, this shifting idea. So this is a shift to the right by 1 position. And I can also get the new sequence from the basic one. Completely different transformation, we call it. Different way of adjusting it. When we do that, the effect on from the original formula to the new formula is, I'll write it out nice and clearly. Take the basic formula, that's the one I have, and replace n with n minus 1, which is exactly what we did. To obtain this formula, you could see it in two ways. The division, perfectly fine in this case, nothing wrong with that. Move on with your life if you can do that. But there's another way of seeing it. And this shifting has a different effect on the formula, a different link. I literally take out the n and put in n minus 1. That 1 means shifting it one position. It's a little counterintuitive because the minus corresponds to shifting it to the right, which we often associate with the positive direction. It's a little counterintuitive. So there are fancier transformations that we sometimes can't get around. This time we had an option. We won't have an option every time. So if it replaces n with n minus 2, I shift to the right by 2 positions. If it replaces n with n plus 1, I shift to the left by 1 position. I know we're out of time. One more quickly. Squeeze it in, otherwise it's just out of place. I believe, do we have a Q&A session tomorrow? I don't remember. We might. So let me just check the schedule real quick. Yeah, we do have a Q&A session tomorrow. So bring your questions if you're not sure about any of this. We can do more examples. There are many, and we can talk about it and everything. Let's just try and quickly finish this one. So here I want to notice that the numbers in the sequence are these last ones, the cube numbers, 1, 8, 27, 64, what was the next one? 125, of course, and so on. And I know that one, it's n cubed. This is just a shift again. See? It's just shifting to the right again. Shift to the right by 1. Shift to the right by 1 position means that this sequence has a formula that I can find by replacing the n with n minus 1. Minus corresponds to right, moving it to the right. Number of positions is, of course, that number over there. Now, as you do the problems, I'll show you real quick here, problem 1.5. As you work through all 11 of those, by the end of that, you should be much more comfortable than you may feel right now. We can certainly talk about these tomorrow, but in general, I do encourage you and expect you to work on something first. If you just say, oh, can you do problem 3 for me, or number 3, and I do it for you, it seems much easier than it actually is, and I could do you a disservice when it comes to the test, right? You have to struggle with it a little bit, scribble some stuff, try and figure something out, try different things, work with it first. And if it still doesn't work, or you just want to verify your answers, absolutely, I'm happy to talk about it. But there's a key aspect to the learning that you have to struggle with it a little bit first. So do that. We have problems, we have things to practice, review. You have to master what we do in the video first. Don't rush to the problems if you don't understand these exercises first. And let me know if you have any questions. Are there any questions right now? I know we went a little over time, but these things happen. Sometimes we will not go to the end time. Any thoughts or questions right now? All right, then I may see you tomorrow. Remember, it's optional. It depends on how you want to use the time. The time is there. Use it as you need to. There's no penalty for not showing up to a Q&A session. It's just there for you to use if you need it. So maybe I'll see you tomorrow, or maybe I'll see you the day after. Until then.